Look at the standard Western breakfast. It is a massive influx of refined sugars and processed carbohydrates dumped directly into your biological system upon waking. This graph tracks the immediate physiological consequence. Blood glucose levels spike aggressively, forcing your pancreas into overdrive to manage the load, only to plummet just a few hours later. That sudden drop severely drains your cognitive function and physical energy. It operates exactly like a memory leak in a computer system, quietly consuming your available processing power before noon. Running your body on high glycemic carbohydrates is an obsolete protocol. To restore baseline physiological function, we have to completely refactor the architecture of our morning fuel. For decades, agriculture engineered modern wheat to maximize industrial scale and raw yield. It was strictly optimized for the machine, not for human biological efficiency. By refining the grain to extend shelf life and speed up production, the milling process stripped away the vital structural minerals and complex fibers your body actually requires to run efficiently. The solution requires stepping back from industrial processing and looking at ancient, unrefined green profiles. These structures have remained intact and nutrient-dense for millennia. Grains like amaranth and sorghum are excellent candidates for this biological upgrade. They contain no gluten and pack significantly higher mineral densities than standard commercial wheat. But there is one specific crop that severely outclasses the rest of the market. It is a drought-resistant ancient grass known as ragi, or finger millet. Integrating ragi into your morning routine serves as a foundational pivot, establishing the necessary conditions for a more stable metabolic baseline. To understand exactly why ragi dominates, we need to run a strict A/B data test on the nutritional specifications of both grains. This chart measures the rate of energy release. Whole wheat sits at a highly volatile glycemic index of 70. Ragi stabilizes between 54 and 68, offering a controlled, steady release of energy into the bloodstream. While legacy wheat holds a slight numerical advantage in raw protein content, ragi completely outpaces it when we examine the essential structural minerals. Look at the primary structural requirement, calcium. Per 100 grams, whole wheat provides roughly 34 milligrams. Ragi delivers 344 milligrams. That is a 10 times multiplier. For systems running on a dairy-free or vegan architecture, this dense calcium payload is critical for maintaining skeletal integrity. Ragi also contains a built-in biochemical rate limiter called tryptophan. This specific amino acid regulates your neurochemistry to naturally suppress appetite and prevent midday overconsumption. The raw data proves ragi's structural superiority, but this theoretical yield remains entirely inaccessible until you bypass a specific biological firewall. Ancient grains survived for thousands of years because they developed evolutionary defense mechanisms to prevent premature digestion by animals and insects. The main component of this defense is phytic acid, a naturally occurring anti-nutrient embedded directly within the raw grain. This animation shows the mechanism of action. Phytic acid chemically binds to essential minerals, forming a stable complex that the body cannot break down during the standard transit time of digestion. Because of this chemical binding, if you consume raw or improperly prepared ragi, that massive calcium payload passes entirely through your digestive system unabsorbed. Traditional farming cultures understood this limitation. They utilized slow, deliberate processing methods like stone grinding and prolonged soaking, which modern industrial food systems abandoned to maximize speed. Sourcing high-grade biological fuel requires implementing the correct pre-processing protocols to neutralize those anti-nutrient blockers. The required technical fix for the phytic acid problem is straightforward. You must treat your breakfast as an overnight batch process. The equation requires exactly 3 variables: raw ragi flour, a liquid base like water or milk, and a mild acidic catalyst. A spoonful of yogurt or a squeeze of lemon juice provides the necessary acidity. You mix these elements and let them sit. Overnight, a slow biochemical fermentation takes place, continuously altering the state of the grain. That slightly acidic environment systematically degrades the phytic acid concentration. By morning, the calcium and iron are chemically unbound and fully accessible for intestinal absorption. For systems requiring a specific boost in hemoglobin, there is an optional advanced module, sprouting the ragi whole grains before milling them into flour. The physical sprouting process triggers a massive spike in vitamin C. That chemical addition dramatically increases the bioavailability of Ragi's 11.3 milligram iron payload. To extract maximum biological value from this ancient crop, we have to prepare it deliberately. High-density nutrients only provide value if they are rendered bioavailable before ingestion. The final execution step happens the next morning. You apply low heat to the activated soaked malt, cooking it briefly to create a highly digestible porridge. This graph illustrates the resulting biological state. Instead of a volatile spike, activated Ragi provides a smooth, rate-limited delivery of fuel to your brain and muscles. You bypass the sudden mid-morning crash and eliminate the cognitive brain fog that inevitably follows the legacy wheat system. The runtime effects are highly stable: sustained energy release, appetite suppressed by tryptophan, maximum skeletal support delivered through fully bioavailable calcium. By replacing high glycemic carbohydrates with activated Ragi, human runtime performance shifts from volatile to fully optimized. This process forces us to look critically at how we architect our daily habits and select our inputs. Modern mechanized farming succeeded at optimizing yield for the machine, but doing so compromised the efficiency of the human engine. Reclaiming an optimal baseline of health requires adopting the older, unrefined architectures that human biology actually recognizes and utilizes. If you want to deploy this upgrade in your own routine, I've linked the specific measurement ratios and the recipe in the video description below. The data is clear. Stop crashing your system with legacy code and start your morning with a structurally superior fuel.